All right, now that we've talked about trapezoids, we're going to move on to our second type of special quadrilateral that is not a parallelogram, and that is a kite. Sometimes people like to refer to these as diamonds. Kite is really the technical term for it. At least that's what we're going to use here. So a kite, K-I-T-E, is a quadrilateral with exactly two pairs of consecutive congruent sides. With exactly two pairs of consecutive congruent sides. Almost need another blank there, don't I? Oh well. Consecutive congruent sides. All right, so a parallelogram has two sets of congruent sides, but they are opposite each other. In a kite, the congruent sides are not opposite each other. So, unlike a parallelogram, the opposite sides of a kite are not congruent or parallel. So it's got some characteristics kind of like a parallelogram, but not quite. And there's no parallel sides on a kite, so in that way they're very different than a parallelogram, or it is very different. So what characteristics besides the definition does it have? Well, if a quadrilateral is a kite, then we also have some characteristics of its diagonals. These diagonals kind of look familiar to you, maybe, because if you actually fly a kite and it is the traditional shape of a kite, those braces that are vertical and horizontal across the kite that kind of hold it together are like the diagonals, are the diagonals. I was thinking about that right now because kids and I and the family and my wife, we just saw Mary Poppins Returns, and so that reminds me of a kite, of course, as Mary Poppins travels into the movie and the story on a kite. So the diagonals of a kite, I'm kind of sidetracked here. So sorry, if a quadrilateral is a kite, then its diagonals are perpendicular. Sometimes I do that in class too, but not usually when I'm doing a screen recording here. All right, good thing you can pause me, fast forward me, rewind me, so that you don't have to listen to the story if you don't want to. Okay, moving on. So we see that these two diagonals are perpendicular to each other. Notice that the congruent markings are there to show by definition that it's a kite, but then also that the diagonals are perpendicular. 6.26 says if a quadrilateral is a kite, then there's exactly one pair of opposite angles that are congruent. So, similar to a parallelogram that does have pairs of opposite angles that are congruent, a quadrilateral is a kite. The set over on the side, in other words, the ones that are formed by the non-congruent sides are the ones that are going to be congruent. So it does have a pair of congruent angles, but it's the angles between the non-congruent sides. Okay, so let's apply that to our kite down here. So if FGHJ is a kite, find the measure of angle FGFJ, I should say, G to F to J. So that would be this angle right here. All right, so let's look at this. Now, we don't know two of the angles, but think about what we just said. We know that it has one pair of opposite angles that are congruent. So if we think about the fact that it is a quadrilateral, we know quadrilateral angle sum has to be 360 degrees. So if we subtract off 128 and 72, that's going to leave us with 160 degrees. Now that 160 degrees is split equally between these two angles, and sometimes we refer to these as the non-vertex angles. I don't know if this textbook uses that term very much. So basically we have the vertex angles that are the angles formed between the congruent sides. So vertex and vertex usually is kind of like the top and bottom. And then the congruent angles in a kite are the non-vertex angles. So if we divide that sum into 2 equal parts, then we get each non-vertex angle to be 80 degrees, and therefore our answer for the measure of GFJ will be 80, and so would this one for that matter. So 80 degrees. Okay, so remember that characteristic. Part B says if WXYZ is a kite, find ZY. All right, so we're given some measurements along the diagonals here. And we'll notice that by doing that, we create some types of triangles. What type of triangles are created? Well, since the diagonals are perpendicular, we've got some right triangles created. I heard you say that. So let's see, ZY though is actually down here, isn't it? So ZY is on this right triangle right here. And if we know 2 sides of a right triangle, what are we going to do to find the third side? That's right, the Pythagorean Theorem. All right, so what are we trying to find here? I think we're trying to find the hypotenuse. So ZY is kind of like the hypotenuse of this third side, or the hypotenuse of the right triangle. So a squared plus b squared is equal to c squared. We have 2 legs, 8 squared and 24 squared, but we don't have the hypotenuse. So let's go ahead square those. So we got 64. 24 squared is 576. And 64 plus 576 is 640. And what do we do at that point? Take the square root of both sides, and we get C is equal to, well, let's see, approximately, suppose we could put this in simplest radical form. I'm just going to get a decimal in this case instead of reducing it into simplest radical form. So about 25.3. So square root of 640, which is approximately, what do we just say here, 25.3. Rounded to the 10th place anyway for that, so 25.3 units. Okay, so that is what we have for example number 4.